most of it? What's it used for? The chapter spends a lot of time on the energy resources, although there are other resources that are important too. All right, we'll look at the difference between non-renewable and the renewable energy resources, and also some other resource issues too, soil, wetlands, and also end up with ideas about sustainable development. Oh, by the way, we have at UNCP, you can get a minor in environmental sustainability. All right, I'll put that little plug in. Okay, and so it would be great if I could get through at least most of the energy resources in this hour. A few preliminary photos from the book shows that one of the issues is the use of oil. Issues like, are we running out of oil? How many more decades of oil do we have left? What are some of the environmental problems that are created by using oil? All right, where do we get a lot of our oil? Where do we get most of our oil? You notice, mainly because of the war in Iran, the price of gasoline has gone up, but we don't get our oil from Iran. So why is it going up so much? Well, because there's a world market. Because the places where it usually went, then those places have to buy their oil from somewhere else where we were buying it. All right, and so sometimes we demonize the wealthy oil-rich countries cutting off supplies of oil and that. Well, where do we get most of our oil? A lot of it comes from Canada. It's surprising. All right, Alberta, Canada is a big energy producing province. All right, so at some point in this discussion about oil, I open up and ask you to think about, are we dependent on Middle Eastern oil? Well, we don't get most of it from there, but we're still depending on it because we're dependent on the world market for it. All right, so that's a complicated issue, and that sets the tone. This just shows a electrical dam. Resources being wasted here? Probably not. Some naturalists don't like dams, and one of the issues with damming is that most dams are dams because of environmental problems that they might create. But they also solve a lot of energy problems too. It's hydroelectric is by far the most important of the renewable energy resources. You have solar out there. Solar is a tiny percentage of our entire country's energy budget. There's some wind. Yeah, it's alternative energy. That's a tiny, tiny percentage of our energy budget. The one that produces, of the alternatives, the one that gives us the most energy is hydroelectric. Okay. All right. Now, in the opening vignette of your textbook, they always start the chapter with a story that's supposed to set the tone, and I'll read from that over on page 329 if you're following along with the keyboard. The world's richest nation in terms of income per person was how National Geographic described Nauru in 1976, single island country in the South Pacific Ocean. Nauru today is a barren wasteland. And then there's your textbook picture of Nauru. It's just this one little speck of land out in the vast Pacific Ocean. Well, so at one point, they were the world's richest country. Well, how do you get to measuring things like who's wealthy and who's poor and so forth? They had a lot of money coming in because they were selling phosphate rock, which was used as fertilizer in mostly Australia. But there are relatively few people. There's only a little bit of land. So there's only a few people, but a big amount of money. So on a per person basis, everybody had a lot of money. If you take all the money in the country, divide by how many people you are, then they were the richest. that might not be strictly comparable when you have a country that's only a few tens of thousands or even hundreds of thousands or even a million versus the big countries like the United States. But all right, so if you looked at per capita income as a measure of wealth, all right, tiny Nauru, this little speck in the Pacific Ocean, was the world's richest country. Well, posing the question, what resource lessons can we learn from what happened on Nauru? Well, uh, the main resource lesson was that they depended on one resource for their income. They depended on one resource, maybe the same way as we depend on oil. You know, oil runs the country. What happens if we don't have oil? Well, you could probably draw that analogy because their entire economy and way of life depended on the export of the phosphate. Well, here's the thing. The mineral was non-renewable. So, and that's one of the concepts. What's the difference between a renewable and a non-renewable resource? A mineral like this is non-renewable. You can't make more of it within human lifetimes. And so if it's non-renewable, it can be used up, and they used it up. So they went from being the richest country in the world to the poorest country in the world, or thereabouts, because they sold off all of their resource. So you could probably make some analogies, and we could say, well, we could say that about us. You know, it don't depend too much on one resource. Don't depend on non-renewable resources. You could say that. That's what it would say about us as a country, or maybe even us as a world. Because look at Nauru. It's this little speck in the vast Pacific Ocean, the same way Earth is just, you know, one small planet in the vast universe. You know, everything we're ever going to have, everything we're ever going to use is on the planet. So if we don't manage that correctly, then we're in some trouble. The same way as Nauru is in some trouble. They're one little speck. They used everything they had, and now it's gone. So that opening vignette is supposed to set the tone for this chapter on natural resources. Okay. Well, my old resource geography professor had his old adage that he used to say. He used to say that resources aren't, they become. So resources aren't resources? They aren't resources, they become resources. So I was trying to figure out, what did he mean by that? Well, to look at that, we have to see that what a resource depends not only on its physical existence, but also as the human perception of it being a resource, so it could be exploited as a resource. I mean, the picture from your book is this one of like a mixed forest in the eastern United States, Virginia, West Virginia. All right, so what's the resource here? Well, to the original inhabitants, the resource was the forest. The forest was a place for hunting and gathering, so that's what the resource was. But then later, when settlers from Britain came in, they looked at this. So the forest isn't a resource. The forest is actually in the way of what's important. What's the important resource? It's the land. It's the agriculture for growing crops. So the trees are just in the way. Yes, you can cut them down and you can use them for building material and you can use them for firewood for fuel, but that's not what the resource is. It's agricultural land. So what a resource is changes over time. And then later, more sophisticated industrialists came in, and they look at that scene, and then you ask them, what's the resource there? Well, they're not interested in the trees, not interested in the land for agriculture either. So all that gets scooped away. What are they interested in? They're interested in the mineral resources under the ground. They're interested in the coal and the iron ore that you can put together, especially if there's a river trickling through there, to put them together for steel making. So did the original inhabitants see the coal and iron ore as the important natural resource? No, because if they're hunter-gatherers, then they didn't see that as a resource. All right, so what he meant by that was that resources aren't, they become. Resources become resources because resources aren't resources until a culture perceives them as one. Okay. I draw this to your attention because there is a question in the quiz bank. You may pull it on the next exam or for the final. And let me ask you this. If you didn't have that discussion that I just told you just before this, honestly, what would you answer if you were posed this question? Whether material is considered to be a resource or not is a function of what? Well, certainly, according to the textbook definition, it's a naturally occurring physical thing, exploitable material. So shouldn't it be B, right? Could it be C? The economic situation of a particular country. Well, economic situation. You mean development or economic? Even if you're really desperate, it would be a resource. Otherwise, not. If there was plenty, it wouldn't be a resource. All right. And then the location of the material. And I have to think, well, that's a factor too. Because whether or not it's feasible to get at that resource, it depends on that. Here's what the answer is. The answer is the cultural circumstances. And, well, would you have chose that one? Probably not, because the other ones sound pretty fair. But remember, with multiple choice questions and test banks and so forth, the standardized tests, it's always choose the best answer. The best answer is cultural circumstances, because you have to have the perception that it's a resource in order to exploit it. I mean, the most important resource in the world right now might be Middle Eastern oil. It runs the world, right? Runs we get it from there. Oil runs the world. But 2,000 years ago, there's places in the Middle East where it actually seeps out of the ground on its own. Was it a resource? Not much. Okay. Or an example that I like to give is an example of uranium in New Zealand. Anybody knows what New Zealand is? It's a nice country. Where would I want to live in the world? And probably in the southern hemisphere of New Zealand. Nice environment. Get away from most of the world pollution. It's a beautiful place. The Lord of the Rings movies were shot in that location. It's a beautiful place, right? So in the case of New Zealand, just by the luck of the draw of how minerals come up out of the earth and are distributed in clusters, New Zealand has significant uranium underground. But New Zealand is a very anti-nuclear country. They don't have any nuclear power plants. They refuse to build them because of their environmental ethic and fear of the dangers of nuclear power. They won't let nuclear-powered naval vessels dock in their waters, even though New Zealand is technically an ally of the United States. It's a nuclear-powered vessel, it can't dock. They're very anti-nuclear. Well, how do you generate nuclear power in the standard case, right? For peaceful purposes, for electrical generation, you split the atom, you split the uranium atom to release heat to boil water to generate steam to turn turbines, is how you generate electricity. Oh, well, all the electrical generation was. You know what you're doing? You're boiling water. We mine coal to be used in our power plants. Well, how does the coal make electricity? Well, you boil water to generate steam to turn turbines. What about natural gas plants? Well, you burn gas to boil water to generate steam to turn turbines. So all the fossil fuel, anything that you're burning to doing that. So nuclear power is basically you're boiling water. All right. Although you're not polluting the air with the carbon dioxide. So you need uranium. New Zealand has plenty of uranium. So is it a resource? They don't want to use it. It's not perceived as being a resource, so it's technically not a resource. So that's why I think it's a difficult thing here. I would not blame you if you answered any of the other ones, because you could probably make a point to one, but that's how it keys out. Whether material is considered to be a resource or not, it's a function of cultural circumstances, and it goes back to my old resource geography professor. I'd always said, resources aren't, they become, as he talked like that. At first, I wanted to make sure I understood what he was saying. Resources aren't, they become resources. Okay. All right. So need to officially distinguish between what's renewable and what's non-renewable, and then maybe make a distinction between renewing something and recycling something. All right, let's take a look at the schematic. And of course, if you're going through the Smart Book right now, you'll notice that you have several questions about this, and they look for examples there. All right, so renewable and non-renewable. It reminds me of that old expression, you can't have your cake and eat it too. All right, that's non-renewable resources, right? Because if you eat your cake, you don't have cake anymore. Well, that's the way non-renewable. I mean, they're non-renewable within human lifetimes, and that nature can't replenish them. Now, the examples of that are all the fossil fuels. And sometime today, I got to touch on all of these. So if you burn your coal, you don't have it anymore. If you burn your oil, you don't have it anymore. Your natural gas, tar sands, there's a little bit of oil in those, and then also oil shales too, and shale oils. Not the same thing as oil shales. All right, so if you burn those, you don't have them anymore. They're non-renewable. Okay, and then all of your minerals, gold or copper. Copper's a good one to talk about. Copper is non-renewable. Like, I know what you're going to say. You're going to say, well, copper can be recycled. Yeah, but that means it already existed, and you're just changing the form of it. You're changing it from copper pipes into copper wiring, or a copper statue into copper wiring, or something like that. You can change its form. That's you can recycle it, but nature can't create more copper. You're not going to have in human lifetimes those ores coming up out of the earth in a substantial degree, that there's more copper in the world. And what we're doing with copper is that we're mining lower and lower grades of ore of copper. Nowadays, what they call copper ore is a fraction of a percent of actual copper in it. All right, so it's non-renewable, so you have to think about substitutions and that type of thing. All right, so for the non-renewable, you can't have your cake and eat it too. For the renewable resources, you have the ones that are perpetual versus the potentially renewable. The perpetual resources are there, well, they're perpetual. They're there forever. There's nothing that human greed can do to use up the power of the sun, right? Or even the amount of sunshine that strikes the top of the Earth's atmosphere. There's nothing that we could do to use up the power of the sun or the wind or the waves or the heat coming up from magma. In all of our greed, we'd never be able to use that up. They're perpetual. The thing about those types of renewables like solar and wind is that the apparatuses to exploit that energy isn't free. You need to build something in order to use that. But if we can and when we can, they're there forever. Okay, we're not going to use up the wind. Versus potentially renewable. Can you list an example of a potentially renewable resource? I mean, it should be renewable, but only if well managed, meaning that you can use it up so that you don't have it anymore. Things like water or groundwater. All right. Yeah, we get a lot of our drinking water from groundwater. There's a lot of irrigation with groundwater, the drier areas of the country. Well, water is a renewable resource. Every year it rains, the water percolates down into the ground, and you can pump it out and irrigate again. Yes, but the thing is, though, if you pump it out faster than nature is replenishing it, you're using it up. They're doing that in some areas in northern Africa and the Arabian Peninsula. They're tapping into ancient aquifer water that hasn't seen light in tens of millions of years. And they're pumping it out. They're pumping that out. It's not going to be replenished, right? They might as well be pumping out oil. It's gone. And things like plant. Well, I have to say plants here. My archetype for a potentially renewable resource would probably be forestry. Okay, right? A lot of ecologists they get upset when trees are cut down and that sort of thing. Here's the thing about that: trees grow back. You cut them down, they'll grow back. So as long as it's well managed, you should have forestry products, lumber and other things forever, as long as they're properly managed. Now, the problem comes in when there's too much deforestation, clear cutting, where you can ruin ecosystems and it's difficult for them to come back. And the same with soil, too. 100 years from now, you might not be using gasoline to drive your car. 100 years from now, you might not. But, we're still going to be eating things that were grown in the ground. So the soil is a very important natural resource. It's not respected much. So soil is perpetually renewable, yes. We should be able to grow things forever. But if the soil is eroded or overused and it's gone, it takes a long time to get it back. All right. So yeah, and so yeah, my example. So if I ask you, what's a good example of potentially renewable resource, then forestry would probably be one. Trees would be one. You could say groundwater. It's renewable, no doubt, but only potentially. Okay, so I had those. Right. And this is what I told you. Right? And so the old adage is, right, for non-renewable, you can't have your cake and eat it too. So renewable resources, and I should have said this, renewable resources is how you can have your cake and eat it too, because it replenishes itself. Okay, something else, resource terminology. You have some questions about this. You have questions about what a proved reserve is. And so you have this complex table. Whenever you're reading a graph, make sure that you understand what the axes tell you. All right, so on this axis, you have increasing economic feasibility. That means is it there or not? feasibility. Feasibility means we can do it. It's feasible. We can afford to do it. It's feasible. Some things are possible, but can you afford to do it? All right. So that's increasing feasibility. And this axis is increasing geologic assurance. All right. So it's down here. Yeah, we're pretty sure it's here. It's down there. As you go on this axis, we're not so sure it's there. But here in this graph, they've divided up into sections. So it's pretty well cut and dried what's identified versus what's undiscovered. All right. So a proved reserve of a resource is the amount it's been identified and it's economically feasible to do it. All right. Now, it probably makes sense to actually attach a resource name to the the resource example to make it a little bit more understandable. So the one you could probably use is probably oil. Okay, what's the proved reserve of oil? When you're talking about volume of oil, sometimes it's billions of barrels, but those are cumbersome numbers to use. Usually when you talk about proved reserves for things like oil, you talk about how many years do we have left, meaning at current rates of use, how long will that last us? Now, there are different estimates on that. And if you look at 5 different sources, you might see 5 different answers. Ask 5 different geologists, you might get different answers. If you talk to Dr. Farley, the chairman of the department, he used to work for Exxon, he would love to tell you an answer to this. You might get a different answer than what's in the textbook. In the textbook, it says 40 years. Well, the textbook was written 5 years ago. So does that mean 35 years? So at current rates of use, the world's going to run out of oil at 35 years, according to, all right, that's the agreed upon estimate. Some say it's a lot more. Some say it's less, and we're past it now. All right, so we'll say, all right, so the proved reserves for crude oil is 40 years. All right, so because we know where that oil is, and we have the technology to go get it. But is there some oil in the world that's at point X and that it's undiscovered? We don't know it's there. But if we did know it was there, we have the ability to go get it at current costs of extracting that. The thing about that, well, for oil, there's probably not that much that's undiscovered. Geologists have mapped things out pretty well, although we're thinking now there may be deep subterranean oil formed by different methods. That may be. Well, it's still undiscovered. All right, so there's probably not a whole lot that can extend into that. Although when there is a discovery, though, it reduces the price of oil. It increases the proved reserve. A good example of that is the North Sea oil fields around the British Isles, Norway, Scotland. In the 1970s, there was the big oil shocks, the Arab oil embargo, the Iranian Revolution. And so it forced Europe and other countries to seek and find other oil at current technology. So they use offshore oil in the North Sea. Started tapping into that and made the world price of oil go down quite a bit. So by discovering that, it extended the years of how much oil there was in the world. All right, let's see. And then you have some that's been identified, but it's sub-economic. I mean, it's not economically feasible to do it. And that might be a lot of this oil that's in the Arctic coastal plain, Russia and its continental shelf. We know there's a lot of oil there. There's a tremendous amount of oil there. There's more oil there than probably any of the other areas in the Middle East. It's under the Arctic Ocean. Oh. So you would expend more energy going to get it than you would get out of the oil. But then someday, though, it may be that that's tapped into, and that'll extend the proved reserve of oil and how long we can keep using it. And technology does change and increase proved reserves. If you would tell a geologist 50 years ago how deep would we be drilling offshore in the Gulf Coast, Gulf of Mexico, Gulf of America, how far would be drilling in 2026 as opposed to 1980? They never would have believed you. It's just not possible. We don't have the technology to drill that way. Or the Alaska North Slope oil. Back in 1980, it said it's impossible to get it without wrecking the environment. Well, now it is possible to go get it and have technology to get it out a lot more cleanly. So that's extended it. So if you extend the amount that's been identified, then it makes it feasible. All right, but there is some oil that's been identified, but it's subeconomic. That would be the Arctic Ocean oil. We know it's there, but it's not feasible. But then there might be some that it's undiscovered, and if we didn't know where it was, we wouldn't be able to get it anyways. All right, so that's one example of one resource. And this is what I just told you. Right? These are all the terms. What a proved reserve is. You'll probably see a question on what a proved reserve is. I know you see it in your smart book, but might see it on a quiz too. Yes, a proved reserve can change over time, as I was saying. You can extend that. Okay. Moving on. For energy, your textbook goes into some discussion of the physics of energy, and the video clip that I posted for today, I don't think I'll get to that today, but that video clip does look at the energy sources of the Earth, and they get into a little bit of physics, and some of that is beyond what we can do in Geography 1010, but the energy, the capacity to do work, and so forth. There is a good geography example for the difference between potential energy, the energy of by virtue of its position, versus kinetic energy, which is the energy of motion. The kinetic energy, that's the water flowing over the dam and turning the turbines. The water back here has potential energy by virtue of its position, and then when it goes over the falls, it turns it into kinetic energy, energy of motion, which can be harvested. Okay. I won't spend a whole lot of time with that. One of the questions asked, in the natural resources chapter, I've highlighted the answers to a lot of the quiz questions in red there. So here I've made those distinguishable. That's an answer to one of the questions. So the question is, why are energy resources the master resources? Are you supposed to think about that for a while? Well, if you want to use any other resource, either it's agriculture or using lumber from trees or whatever it is, it takes energy to go do that. So that's the reason why. So why energy is such an important concept to go over. All right. Now, usually what I like to do is go around the class and I ask students this, and we come to a conclusion. For this question, can it be said that the sun is the ultimate source of all energy? Well, it'd be great if everything was solar powered. That would be great, right? Because the solar power is free. So can it be said that the sun is the ultimate source of all energy? And here's how I do that usually, is that I ask students, do you have solar powered car, and they go, well, no, it might be electric car or hybrid, but it's not solar power. And so I ask, what is it that powers your car? And then they say, well, it's gasoline. And then I ask, well, where did the gasoline come from? And then they say the gas station. Okay, because they're right. All right. Well, then where does the gas station get it? The oil company comes and delivers the gasoline. Okay, and then I have to ask, where does the oil company then get the oil that they turned into gasoline? I go through some steps of refining and where did the oil company get it? And then they say, well, they get it from under the ground. Okay, and then I ask them, okay, well, how did the oil get into the ground? Then where did it come from? And there it becomes a lot more fuzzy at that point. Where did that come from? Well, what that is, if it's a fossil fuel, right? It's ancient plant life. A lot of the ancient forests, mostly it's the ancient phytoplankton that lived and died and settled down on the bottom of the ocean over millions of years. It was compacted. There's a series of accidents that creates oil that's beyond Geography 1010. But sometimes it's said that when you're putting gas in your car, you're putting a dinosaur in your tank. Well, meaning it's ancient life. All right. Well, anyway, so it's mostly the phytoplankton. Well, how did the phytoplankton get to be, or how did they get their energy, which would later be buried, and then later we would tap into their carbon and that. Well, they got through photosynthesis. So that's the sun. You see? All right, so that's just that one. What about wind power? Well, what drives the wind? It should pop up to you because I think I said this. Weather and cloud, unequal heating, causes temperature gradients. The wind blows around. So it's all you could make the argument, and this is by telling a story, especially the gas station story, that ultimately it's the sun. So do you drive a solar powered car? Well, indirectly, maybe. Okay. Uh, all right. So taking a look at some of these resources, at one time, our country ran on renewable energy resources. Shouldn't we get back to that? At one time, we used a renewable source. Well, what was that? Well, wood. Right, is earned for fuel and cooking and that. So we made the transition because it works a lot better to use the fossil fuels, although it's non-renewable. So that's the base of wealth. All right. One of the questions is, what's the correlation between energy consumption and gross national income per capita? Do I have to explain the latter? Probably. Looked at that partially in the chapter on population geography, how you compare standard of living and that. All right, so the question is, what's the correlation between energy consumption and gross national income per capita? All right, this is the question from the bank. They used to spend more time on this in the book, and they used to have a figure. I wish they would have put in another figure. Now it's discussed, so you get a test question about it, but I would have rather have had the figure, I think. So I'm going to show you the old figure, even though if I start saying 1990, that's ancient history. To you haven't been born yet. All right, let's see. So some things to unpack on this slide. All right, always look at your axes. Right? Whenever you're taking any kind of test, graduate admission or whatever it is, you got graph data. If you understand what's on the axes, you've got a beat. You know the answer to whatever question they're going to ask you. All right, so this is energy consumption per capita, not how big the country is, but on a per person basis, how many BTUs are you use. And then this one is gross domestic product per capita. Okay, so that's all the wealth that's generated in the country, divided by how many people there are. Okay, so you see it kind of makes a line, doesn't it? More or less. There are some countries that are outliers, but it does seem to be that countries that are way down here on wealth, even on a per person basis, the US, Germany, Japan, are way down there. But then on the energy consumption axis, they're way up here. Whereas some countries, and generally what we say are the poor countries, all right, so Morocco, India, Bangladesh. Now this is 1990. Maybe India's moved up the list. Is China in there? I bet China has moved all the way up here. Although, yeah, I bet they're about right up there. Okay, so you see that there's a line, and that the richer countries use a lot of energy on a per person basis. Yeah, the rich countries, they use a lot of energy, but on a per person basis. Whereas in poor countries, they don't use so much energy per person. So it's often said, shouldn't we be more like the less developed countries, the poor countries, and use more natural things and not use so much energy? All right, let's answer the question. With respect to the relationship between GNP and energy consumption, is it A? Former decreases, the latter decreases. Okay, hang on to that. As the former increases, the latter decreases. Which one's former? GNP or energy? GNP. Oh, to be test-wise, you get questions, the former and latter. Sometimes I forget. Well, which one was the former? Which one was the latter? All right. So the former. It could be B. As the former increases, the latter decreases. That would mean as you get wealthier, you use less energy. Doesn't seem to be the case. There's no relationship. Yeah, that's for you go. I don't know. It doesn't look like there's any relationship to me. The answer is they both increase directly with each other. Right? So you keep going up here, you go over here, yeah, you go over there. You go up in wealth, you go up in energy consumption, you go up in wealth, you go up in energy consumption. It goes all the way. It's pretty linear. So the answer is they both increase directly with each other. If that's the case, why can't it be A? If you were taking the paper test, you might ask me, wasn't that the same thing? As the former decreases, the latter also decreases. Isn't that also true? As you go down the line, it also decreases. It seems reasonable at first, doesn't it? But no. You know why? No one ever goes back. No one ever uses less energy this year than they did last year. Every country, everywhere, always uses more energy than previously. Yeah, we can cut back, we can slow it down, but it only works in a one-way direction, especially as countries develop, as they go from being poor countries to middle-income countries to richer countries. As their standard of living improves, energy use improves. Can you improve standard of living without increasing energy consumption? Probably not. And that's the problem, is that the poor countries of the world want to develop. But in order to do that, they have to use their energy resources. But, ethically, we always say, well, we need to cut back. Well, then that means that you don't want the less developed countries to increase their standard of living. Of course they're going to use, of course they're going to increase their energy use. And what's the source of that energy? Fossil fuels, almost entirely by fossil fuels. So is there any chance that we can reduce our fossil fuel use? That's the problem, because right now it seems to be tied to development. Oh, and then this already popped in, but usually I pose this to students. Do we use a lot of energy just because we're rich? Right? You leave the refrigerator door open, well, you don't care. You're not paying the electric bill, right? Or you leave your car running, and well, you don't care. You're rich. You got money to burn. You leave the front door open, letting the air conditioning out in the summer, letting the heat out in the winter. But you're a college student, right? You paying for anything? Well, you don't care. You're rich, right? Is that the way Americans are? Or the developed world are? We use a lot of energy. We don't care because we're rich. Although, in reality, it's this. We're rich because we use energy. It takes money to make money, right? You've heard that. It takes energy to make money. So as the world's poorer countries strive to become richer, they're going to use more and more energy, and that energy is going to be fossil fuels. Okay, we'll hope we'll lessen the amount of consumption, slow it down, find more efficiencies and substitution, but it's going to be that way. All right, sources of energy in the United States. I have the old figure and I have the new figure. This is the new figure. And I'm not sure I like this one as much as the old figure. This is the source of energy, right? The commercial energy in the United States. I'll take a quick look at it and then go back to the older graph, which I think is better, even though it's, it doesn't have the recent decade. All right, so let's see. You see this the line here says wood over time? At one time, wood was the majority of commercial energy in the United States. Yeah, wood fires, charcoal, right? Before coal, you run a steam engine off of wood. All right, that's amazing, isn't it? But coal took over. And so this is the Industrial Revolution, the railroads, beginnings of trade. Coal went up, and it's gone through its peaks and valleys. There was a depression in there; it's gone back up. And the 80s, burning a lot more. A lot of this is for electricity, and then it's turned down. Though there's been a view that coal is dirty business, and we got to find some substitutes. So a lot of the coal burning has been replaced with natural gas burning or even oil burning, and a little bit of the nuclear power, which is not a fossil fuel, but it's an energy source. So it's gone up and down. But worldwide, it's actually reversing. The world is using more and more coal every year. I thought we were cutting back on coal. I thought we wanted to put the coal miners out of work to clean up the environment. Well, not worldwide. Worldwide, the less developed countries are using the coal. They're using more and more coal every year. We're using less. All right. Well, that's a whole other story, whole other argument. All right. So, petroleum's the major one. That's the major one. Okay. But I wanted to go back to the graph because I want to get you good at reading graphs, even though I know it ends in 2008. But we're going to assume the trend is going to go. All right. So this is the percentage of commercial energy in the United States. What explains it? Okay, and so each one of these blocks is 10%. So, for example, what percent of commercial energy in the United States today, if today is the end of the graph, is explained by coal? Well, there's 10%, 20%, so I don't know, somewhere around 25%. the commercial energy in the United States is from coal. That sounds reasonable, maybe a little bit less, but then we have to use more electricity, so it's going to, but that's reasonable. So somewhere a little bit less than 25% maybe is coal. You know, at one time it was wood. Wood ran the country. Okay, how about oil? This is how you read the graph. What percentage is explained by oil? You don't read it from this number here, because that's putting coal into your number. So it's got, 10, 20, 30, and then about 5 on either side. So about 40%. So 40% of our energy use is oil. Natural gas is going up a little bit. Oil and coal are going down a little bit, but let's see. So for natural gas, I don't know, what, 25%? And then, all right. So some questions that can be made from this. What percentage of our commercial energy is from fossil fuels? Add up coal, oil, and natural gas. About 90%. Fossil fuels. Well, which are non-renewable. So how are we like Nauru? We're basing our economy on something that's non-renewable. Well, what about nuclear? Nuclear is not a fossil fuel. It's an energy source. It's also not renewable because uranium is non-renewable. If you dig it up and you use it, you use it up to a point. So uranium has a proven reserve. But uranium, as far as a non-fossil, that's our most important non-fossil fuel, is nuclear. But now if you add together the non-renewable, nuclear, and the fossil fuels, now what percent of our economy is based on non-renewables? Almost all of it. 95% is non-renewable. Well, and what is renewable, almost all of that is hydroelectric. Solar and wind, not so much. Now that's changing because there's a lot of subsidies for things like wind farms. Are finding out that those are leveling out on their efficiency and cost benefit of them, and solar as well. As far as running the country's never going to be run off of wind or solar. It's going to be run for a long time off of fossil fuels. It's good. You can have it where you need it. Say local wind farm, solar power on roofs, which I always want people to do. Instead of the black slate tile roofs. If everybody has solar collectors, right, on your roof, right, and then you charge your battery in your garage, come in and plug your electric car into that every day. That'd be great. We don't have it though, because what runs the country is oil. So the whole trick is deviate from that. All right. So a small sliver, other renewable. It has gone up because there's been a lot of investment subsidies to do it. All right. Energy resources, right? So this is what you're supposed to do. These are the energy resources. Crude oil, okay. But I said that. As we go through some of the other slides, we got to look at the geography of it, and not only what it is, where's it located, who produces the most, and what's the meaning of it, what kind of social cost. I've already actually talked about a lot of this already in my lead up, using oil as an example so often. All right, so 40. What do you make out of oil? Right. Transportation. So you make oil into gasoline, diesel fuel. So about 2/3 of it is used for transportation. Now you can make all kinds of things out of oil. Anything that's plastic, it's made out of oil. Okay. Right? Gee, is there anything that is made out of oil? Can you make food out of oil? Yes, you can. What about petroleum jelly? What's that made out of? Oil. What are 1970s disco suits made out of? You've never seen one, right? You ever seen one? What are they made out of? Polyester? What's that made out of? Oil. All right. So yeah, all this stuff, it's made out of oil. Compact disc made out of oil. Most of it's for transportation. I'm old enough. I remember back in my day, had the oil shocks. And so, a question later is, who's OPEC? Organization of Petroleum Exporting Countries. It's a cartel, international cartel that tries to manipulate the price of oil on the world markets by increasing production or decreasing production to affect the price. It's a cartel is OPEC. I have a slide on them that occurs later. Might as well talk about it now. OPEC is a cartel. Cartels are illegal in the United States. You can't have companies get together and set the price of various products, although it seems like they do. Cartels are extremely illegal in the United States. You can't do it. So how do they get away with it? Because it's not the United States. It's the world. The world can do whatever they want to do. So countries can do that. All right. So it's been decades. All right. Everyone's always been saying we have to reduce our dependency on imported oil. And we did make some turnaround recently, and then it went up and down. Now it's going back down again. We're getting more from the United States sources. All right, so the biggest shocks in the early 70s and in the Iranian Revolution as well, the price of gasoline shot up. We used to, in the 60s and 70s, used to drive around these big cars made out of metal, but doing that. So what do we do? Alternative sources, the North Sea. All right, there's a lot of history. There's getting into some history on that. But certainly everyone agrees that we import too much oil, or we're dependent on the world oil, even if we're not getting it directly from them. All right. Yeah, so a couple answers here. Looking at the map. Is there a map? That's the shipments. That's the approved reserves. That's a few years old, right? So what world region has most of the reserves, or in the Middle East, is the answer to that. Now, a geographer would not like a map like this. You might as well put this in a table, because is it mapped information at all? Not so much. Right? Especially South America, most of that is the Venezuela, the Caribbean facing countries. It's not really a logical thing to do. All right, so some of the things you have to get here. Okay, let me wind up in a couple minutes because we didn't get the video break today. Largest reserves are in the Middle East. Depends on who you talk to, though. Some say we're past peak oil. Some say, well, look at the rest of the world that's still developing. They're still tapping into oils as much as possible. It might be that there's some undiscovered, it's the Arctic Ocean oil that could bring it back up. What's this? This is supposed to show, all right, this is supposed to show the producers versus the consumers. And unfortunately, it's by country. All right, so production, does this surprise you? Maybe not. But because we think of the U.S. as being the big consumer, like a junkie, or a junkie for oil, worse than the worst heroin addict, depend on oil. But does it surprise you that we're a major producer in the world? In some years, the largest producer of oil? Because you think, well, like Saudi Arabia, Kuwait, Kuwait's a little country. We're a big producer. We're also a big consumer. Some of this would have to be reversed, though. Probably China, since they made this graph 2019, they're probably a lot higher there. But what you see is the industrialized countries are the consumers, and these are the producers. All right. shipments. Well, what you see on this is you see the graduated flow line. Look at the lines that come from the Middle Eastern region. Is that the majority? Yeah, that line says 70. I know it's a few years old. 73. Where are the big thick lines? You get a thicker line here come from Mexico. You get a lot of oil from Mexico. Get a lot of it from Venezuela. You may pump up the production now. And look where this big sliver comes from. Canada. You mean out in Quebec with the maple trees? No, it's Alberta. Alberta is a energy producing juggernaut. Oil, oil shales, tar sands. It makes a big mess up there. They're a big energy provider for the United States. So yeah, it sounds funny to think about it. Yeah, who are these evil oil importer countries? Canada is a big one. All right, all right. So there's a lot of things to discuss, and we're holding back and interjecting in and give some opinions. Maybe we could do that last time. So I'm going to go ahead and end up at this point. You can rewatch that later or share it on social media and so forth, but they have to have the code. You know how to get in and see the recordings. Have we ever done one before? There was one other one, wasn't there? The lecture was recorded during the school closure. Oh, maybe not. You go to the WebEx link and the recordings, and you cut and paste the password if you want to see the lecture videos. All right. All right, I'll see you Tuesday.